So we have been able to identify quadratic relations from a graph, right? We just look at the shape and either it is like this or like this. We can also figure it out through equations and t-charts. So remember our table of values? Yeah, we get to go back to that. But first, we're gonna take a quick look at how to sub in information and solve. So for question A, if we are given x equals 6 and we are to solve for y, what we're going to do is take our 6 and plug it into the x value. So we have y equals 2, put it in brackets, plus 10, right? And then we have to remember all the time for BEDMAS. So multiplication comes first. So 6 times 2 is 12. And then we do plus 10, which is 22. So when x is 6, y is 22. And now we're going to plug it in here. So we have x equals -3. And what we're going to do is we're going to take -3 and plug it into the x. So then we're going to end up with y equals -2 times -3 to the exponent 2 plus 7. Now remember with BEDMAS, our exponent here comes first. Okay, so -3 to the exponent 2 gives us 9 plus 7. And then -2 times 9 gives us -18 plus 7. -18 plus 7 gives us, -11. So the one thing you need to always remember is BEDMAS. If you have to write that on the side, always write it. And then so if we were to put that into our table of values for both of these, x and y, and we would figure all this out. When x is 6, y is 22. And same thing here. When x is -3, so go down, -3, our y is -11. Okay? So now, do we remember finding our first differences? So when we go through and we look at, to go from here to here, it's +2. And to go from -6 to -4, you add 2. To go from -4 to 2, or -2, you add 2. And so if it is the same, if our first difference is the same, it means that it is linear, right? Our line is straight. So how do we figure out if it is quadratic? If we have something like this, what do we have to do to figure out if it is a quadratic or not? Well, we have to go to what is called the second difference. Okay, so what we're going to do is we're going to now figure out the difference between this and this. Okay, so we figured out our first difference here. And we figured out that they're not all the same, so it's not linear. Now we go to our second, and we figure out what is the difference between 10 and 6. To go from 10 to 6, there is a -4, right? So 10 minus 4 is 6. 6 minus what gives us 2? 4, -4, -4. So if these are all the same, if our second difference is the same, it means that we have a quadratic. And we have a parabola. Now we're going to take a look at equations. So from our last unit, we remember what linear looks like, right? So if we're going to take a look at, you guys would be doing this in groups, but we're just going to do it here. So if we're going to take a look at the first one, it looks identical to what we had seen in our previous unit. So this one is going to be linear. Our second one, we did not see this in our first one, right? We did not see something. So if we multiply this out, this would end up as x squared, which if you pay attention, if you listen, sorry, not pay attention, you're gonna realize that all of the ones with squared means quadratic. So if we FOILed it out, x times -2 is going to give us -2x. So this one is going to be quadratic. And we don't see an x squared here, but it looks like our linear lines, so it is going to be linear. Same with the next one, linear. But we now see a squared, so this is going to be quadratic, okay? So on and so forth. So again, if we FOILed this out, it would give us a quadratic. Linear, linear, because I don't see any squareds. So these two, because they have, yes, that was not very pretty, but that's okay. Squared, these are both going to be quadratics, okay? So if there is an x squared, it means it is a quadratic. So our summary, our linear is when neither of these have an exponent, okay? No exponents. Whereas a quadratic is when there is an x squared, there is an exponent. So we see the, okay? So let's take a look at this. So if first differences are constant, so again, when we're looking at our table of values, right, when we're looking at our table of values, and we figured out the first differences between these, if these are the same, so if it's 2, 2, and 2, it means it is, our relation is linear, right? It's just a straight line. Our second differences, if they're constant, so we just figured that out. If these ones are constant, it means that it is a quadratic. If neither first or second differences are constant, that means that it is neither. Okay? So if the first ones are the same, it's a straight line. If our second ones are the same, it means it is a quadratic. If neither of them are the same, it means that our answer is neither. So if we go take a look at some examples, so you guys have this sheet. What we're going to do is we're going to calculate the second differences and determine whether the relationship is linear, quadratic, or neither. So we're going to do the first and second differences. So the difference between this one and this one is -5, right? From 15 to 10, we -5. From 10 to 5, we -5. 5 to 0, -5, -5. So we can see that they're all the same, which means that this one is linear, right? Because this is our first differences. Okay, so we don't even have to look at the second differences. Now for B, let's go take a look. So from 4 to 1, we minus 3. From 1 to 0, we minus 1. From 0 to 1, we add 1. And from 1 to 4, we add 3. So the difference between negative 3 and negative 1 is 2. Right? To go from negative 3 to negative 1, we add 2. To go from negative 1 to positive 1, we add 2. And to go from 1 to 3, we add 2. So our second differences are the same, which means that our line is quadratic.